Hello everyone and welcome to day 20 of Festive Tech Calendar 2024. My name is Veronica Kolesnikova and I am joining today from Boston, Massachusetts. I am so excited to join Festive Calendar again this year. It is such a beautiful initiative and I'm always happy to participate in that. Today we will be talking about the power of multimodal models. And here you can see my Twitter handle or X if you want to reach out to me, if you have any questions later. You can also find me on LinkedIn and message me there and explaining why you want to connect and if you have any specific questions for me. I would like to specifically thank the organizers of Festive Tech Calendar for that beautiful template that I can use today, and it is really nice. Thank you so much, and let's go.
Before I move to the content, I would like to introduce myself. Again, my name is Veronica Kolesnikova. I am 6 times Microsoft MVP in AI. I started my career as a quality assurance engineer and then I moved to development and now I have more than 8 years of development experience. And I used to work mostly with Microsoft technologies like C Sharp, .NET, all that cross-platform awesomeness with Xamarin and Maui. I am obviously obsessed with machine learning and artificial intelligence. Recently, I started working more with Java, Node.js, TypeScript, and a little bit of Python here and there for the machine learning work. And my hobbies are dancing, traveling, and aerial fitness, and a little bit of circus here and there. Unfortunately, I didn't find a picture, an icon that I can use here for my aerial fitness, but I do promise you that I have a picture for you in the end that I generated with one of the vision language models. Now I would like to talk about the agenda for next 50 minutes. I'll start with overview of artificial intelligence and machine learning. Then we'll be talking about multimodal models. After that, I will specifically talk about vision language models. What are they? Some examples, how they trained. So we have that understanding what vision language models are. And then I'll be talking about multimodal embeddings. It is hard to cover all kinds of multimodal models and embeddings. So in this session, I will be specifically targeting vision and text. And after that, I will just show you some code. You can see a demo, how you can use those embeddings, how you create vector search, how you can use vector databases, how you can use those embedded models, some vision language models. So buckle up and let's move forward. I'll start with the overview, as I promised, of artificial intelligence and machine learning. They're everywhere. No matter where you go, no matter what you do, if you're a software engineer, if you are a project manager, if you're not even related in any way, shape, or form to technology, you can't escape artificial intelligence and machine learning. So let's figure out how they are related. And I'm sure if you've been following me for some time, you've seen that slide in my other presentations. I just love that slide. I think it explains it really well and it sets up that basic understanding of how artificial intelligence relates to machine learning. And I'll start with just artificial intelligence. Artificial intelligence is a combination of statistics and algorithms, and we as machine learning specialists, as artificial intelligence specialists, as software engineers, we are just trying to mimic human logic and apply it to artificial logic to our programs, to our projects we're working on, to applications that we're building. And that is artificial intelligence. That's not an official definition of artificial intelligence, but there are more than 50 different definitions. So I do recommend you to go and find the one that you like the best. Next level here is machine learning, and machine learning is a subset of artificial intelligence, machine learning models to become better and better at tasks with experience. So with the vast amount of data that we have, we want to use that data in the most efficient way, and we are using deep learning for that and creating multi-layered neural networks. So those models, those applications, they not only can get better at tasks with time, but also they can perform more complex tasks like image recognition, speech recognition, and so on. There are lots of different examples. So if you ever worked with Microsoft Cognitive Services, all of them are based on those deep learning techniques. And the last layer here is generative AI. Officially, it's not a subset of deep learning, but I feel it is fitting below deep learning quite well. So let's pretend that it's actually a subset of deep learning. Generative AI is relatively new to public. A lot of researchers have been working and developing new models and doing research related to generative AI for a while, but it wasn't popular. I think with the release of GPT, with the popularity of OpenAI and their collaboration with Microsoft, those generative AI models, they became really popular. Generative AI can produce new content based on what is described in the input. There are different models that are related to generative AI, like language models, code, image, and now multimodal models. They are also related to generative AI. So it is next level. Those models are actually targeting different types of content. Let's move to our multimodal models and talk specifically about them now. Multimodal models are artificial intelligence systems that integrate and process data from multiple modalities. Those modalities can be video, audio, speech, images, or text information. Traditional machine learning and deep learning architectures are usually unimodal, designed to work with one specific type of input at a time. Maybe it works just with speech or only with images. The most popular is text. Even those large language models that are very popular, they're mostly working with just text. And only recently, with the advancement of, for example, GPT models, starting with GPT-4 with vision, multimodalities became more and more popular. Also, with increased popularity of artificial intelligence agents, we have to use something more complex, something that can target different modalities. So the agents and multimodal models, they are working together. All those multimodal models, they can better understand their surroundings, they can better understand what is happening and get information from different sources and analyze it. At the same time, they can also produce different types of content. I think A simple example of multimodal model is a DALI 3 that can convert text to images. Multimodal artificial intelligence means numerous data types are used in tandem to help artificial intelligence establish content and better interpret context. So, those agents that I mentioned before, AI agents, they are kind of advanced bots. Don't quote me on that. It's not an official description of agents, but I treat them as advanced bots. So they have to rely on those multimodal models. Typically, multimodal artificial intelligence systems are built from a series of the following three main components. First is input module. An input module is a series of neural networks responsible for ingesting and processing or encoding different types of data, such as speech and vision. Each data type is generally handled by its own separate neural network. So there will be numerous unimodal neural networks in any multimodal AI input module. Second part here is fusion module. A fusion module is responsible for combining, aligning, and processing the relevant data from each modality. For example, speech, text, or vision into a cohesive dataset that utilizes the strengths of each data type. Data fusion is performed using various mathematical and data processing techniques. For example, transformer models. Another example can be graph convolutional networks. If you want to learn about transformer models and convolutional networks, I do recommend to check maybe Hugging Face, maybe some Microsoft Learn models where they talk specifically about those. There are also lots of books that mention those techniques. They're not new and they're well researched. And the last module here is output module. An output module creates the output from the multimodal AI, including making predictions or decisions or recommending other actionable output the system or a human operation can use. Here I also included a couple of examples that you can use to check out those multimodal models. They all are targeting different modalities. They also work better with different types of images, different types of text, and just they have different applications. But some of those models can be a good start if you just want to play with multimodal models. You want to try how they work for your specific use case. I already mentioned DALI 3 that can convert text to images, and by converting, I mean generate images based on text description. Then I also mentioned before GPT-4V or Vision. That is a combination of, let's call it, classical GPT model. For example, if you work with GPT-4, GPT 3.5, you know it's a large language model targeting only text information. So it can generate text based on the text. GPT-4 Vision can also process images, so it combines text and images. And then newer model, something like GPT-4o, can actually process speech, text, and images. I know there is a newer version, so-called, or more advanced version that was released recently by OpenAI, and it's all one model. That one is more complex. It can process different types of inputs, but I do recommend to start with something like GPT-4o in order to better understand the multimodality. Also, GPT-4o is faster because it is not included that new chain of thought behind the scene processing. And another example here is something like IDFix 3. It is also working with text and images. And there are lots and lots of different examples. Again, with the advancement of AI agents, we are getting lots of different options for multimodal models. Some of them are open source, some of them are proprietary. There are options to fine tune some of those models. It's a little more complicated for others. So I do recommend to check out other options, and those are just a couple of examples that I'm giving you today. Now, I want to talk specifically about vision language models. I want to explore how they're being built, and at the same time, talk about use cases, why you need to use them, how you can use them, what applications are out there for those vision language models. So, vision language models, they are also multimodal models, but they are targeting only two things, text and images. And there are several approaches or so called families of vision language models. And here I have a really, really good image that explains how those vision language models were trained or can be trained with really good details. So I'm glad I found that image online and I didn't have to create my own. So definitely pay attention to the image. And there are four families of vision language models. I have descriptions on the left, the names of them with some examples actually. So we'll start with the first one. And the first one is contrastive based or contrastive training. It's a commonly used strategy that uses pairs of positive and negative examples. The VLMs are trained to predict similar representations for the positive pairs while predicting different representations for negative pairs. And on top of there, the first part of that image actually displays how it works. There are two parts, image encoder and text encoder, and then it kind of compares image with the text, and based on that it returns that it's a photo of a dog. Or if you are providing a text and want to get image back, then it will get the text, recognize that it's a dog, and then return an image of a dog. And one of the examples is clip model. And actually, I don't want to go into details about clip models right now because I have my next section of video covering specifically embeddings and clip models. Next option here, or the way of training vision language models, is masking or segmentation. Masking, it's another strategy that can be leveraged to train VLMs by reconstructing the missing patches given an unmasked text caption. Similarly, by masking words in a caption, it's possible to train a VLM to reconstruct those words given an unmasked image. An example of a VLM trained by masking, and also VLM that you can use for masking an object, is SAM or segment anything by matter. Basically, how it works, you are selecting a segment that you're interested in. And usually it's an image. I know they support videos. So you are picking an object, masking or selecting that object on an image, and then later on the model will be recognizing that object. And especially it's visible in videos where maybe you pick your first frame, pick an object that you want to monitor and see how it's changing throughout the video, and then the model will recognize it throughout the video and put that little mask on top of it. While most of those approaches leverage intermediate representations or partial reconstructions, generative VLMs are trained in such a way that they can generate entire images or very long captions. Given the nature of those models, they are often the most expensive to train. And one of the examples of generative-based VLMs is Mini GPT. Actually, I've never worked with it. I just put it as an example because I saw it online in a lot of research. People provide that as an example. I think that another good example can be DALL-E 3. It is also generating images, and you can see on the right on that beautiful image that I have in that generative section. You see that it can generate images from text and vice versa. So DALL-E 3 is only generating images from text, so it only covers the left side of that section. Pre-trained backbones-based VLMs often leverage open source LLMs like Llama to learn a mapping between an image encoder, which could also be pre-trained, and LLM. It's important to highlight that these paradigms are not mutually exclusive. Many approaches rely on a mix of contrastive, masking, and generative criteria. And an example of pre-trained backbone VLM is Qwen. I'm specifically not putting any versions or details about those examples. I know the world of AI is moving so fast that something that I'm talking about right now, especially examples, when I provide an LLM or VLM as an example, it is only relevant right this second. I'm sure there are lots of papers being written right now. There are lots of different labs that are working on new LLMs and VLMs every day. So tomorrow we might have different examples. I do recommend to understand at least those families of models, like Clip is a family of model, SAM is a family of model. So even if they move to next version, you can understand where they come from and how they've been trained. Same thing with Qwen. So if you want to check those models that I provided as an example, you're welcome to. And now you know why I'm not talking about specific version or specific functionality of existing VLMs or LLMs or any multimodal models. Now I would like to talk about applications for vision language models, use cases, and you'll see how important it is to understand what models are available, what the use cases. So if you build all kinds of applications. You know, for what application you need to use a vision language model, what application requires just an LLM, and what application needs something more complex that can maybe understand speech and recognize images, objects on those images, and also process text. Because the more modalities each model has, the more expensive is the usage, the more complex is the model. Even if it's open source, still you need to host it somewhere, or you need to access it somehow, and then it can also get slower at some point. So for VLM specifically, you need to remember that there are lots of different applications, and they're quickly becoming the go-to tool for all types of vision-related tasks due to their flexibility and natural language understanding. VLMs can be easily instructed to perform wide variety of tasks through natural language, something like visual question answering or chatting about images, image recognition via instructions, document understanding, image and video summarization, parsing text and handwritten documents, or optical character recognitions. There are so many different applications. And on the right, again, I have really interesting example, a couple of use cases like object localization. You can ask a model, is there one cat behind another? And then the model can actually respond, analyze an image and respond. Zero shot segmentation. You need the model to find a segment with striped cat. So the model can actually return an image with those segments selected for you. Previous applications that would have required a large ensemble of specialty trained models can now be accomplished with just a single VLM. VLMs are very good at summarizing the contents of images and can be prompted to perform specific tasks based on the contents. One example that I have is an educational example. Maybe when you can give a VLM an image of a handwritten math problem, and the VLM could use its optical character recognition and reasoning capabilities to provide the answer to the problem, to first actually recognize what kind of problem that is, and then provide the solution. And the solution can be in a text form, it can be an answer, it can be explanation, or it can be another image. So it depends what kind of task you want the VLM to solve. Before moving to the code and more practical applications of those multimodal models, I would like to talk a little bit more about multimodal embeddings. Most of those embedding models, they are focusing on images and texts, although I'm pretty sure there are other options for speech and videos and other multimodal models. Um, why I would like to actually highlight those multimodal embeddings is I think that retrieval augmented generation, or RAG approach, is very popular right now. Obviously, those VLMs and LLMs, they can't cover everything. They can't be trained on current information. They do have the cutout date for the training data, or maybe you want to use them with your custom data that obviously wasn't used there for training those out of the box VLMs and LLMs. In order to augment information though that those LLMs and VLMs are having, you need to use something like RAG. And in order to actually convert maybe those text and image pairs to vectors and store them in vector database in order to use that database later for RAG approach, you do need to use those multimodal embeddings. And here I have a couple of examples, and on the right again I have a really useful image. Today you see I have a lot of useful images on the right of my slides. So you see here how something like Clip was trained. So they are combining image encoder and text encoder, and then they're kind of matching the text and image. So if you have new images, for example, you want to actually maybe build a vector database with your custom images, you can still use Clip in order to create those vectors or embeddings with your images. So it doesn't have to be a dog or a cat or something simple. It can be as complicated as maybe medical imaging. But at the same time, there are obviously some challenges. The more specific images you are using, the less accurate those models can be, because they were trained on just basic images that we all understand, something that we see every day. So, enough talking about those images, and let's move to examples. And I start with the first one. It is a CLIP model, or contrastive language image pre-training model. It's a neural network trained on variety of image text pairs. It can be instructed in natural language to predict the most relevant text snippet given an image without directly optimizing for the task, similar to the zero-shot capabilities of something like GPT-3. Although GPT-3 is not a multimodal model, so CLIP is different, but it is also zero shot, so you don't need to provide a lot of examples for Clip to actually recognize images and recognize text and then compare, like set up those pairs between images and text. There's also Clip models. They were created by OpenAI. They were trained on up to 45 billion image text pairs, and they can support resolution up to 384 pixels. So that's another limitation. You have really large images, high resolution images, then it might be tricky for those models actually to interact with them. They are just not capable of working with high resolution images. But for maybe you can reduce the resolution, maybe you can resize the images before feeding them to that model and processing them. There are different approaches, so it depends what kind of application you are building. Next option here is Gina Clip, which is similar to Clip. There again, I'm not providing any versions or any specific models because it can change really quickly, and all those models can be outdated tomorrow. But you need to know about those models, because I'm sure newer models will be built on top of those existing ones. So GinaClip is 0.9 billion multimodal embedded model with multilingual support of 89 languages. So something that Clip doesn't have is a multilingual support, and also they support high image resolution. In my experience, Clip worked better. The images that they use for training and clip were closer to what I wanted. So clip really well recognized text on images. It recognized some kind of damages. So I worked with imagery of cars with different damages. And so clip did pretty well recognizing those damages, although that's pretty specific. And Gina Clip was pretty good, but not as good as Clip. Again, you need to test all those models, your specific use case. Some models are better in one things, but lacking in another things. Maybe they've been trained on a lot of animals and nature, and you need to work more with maybe medical imagery. So you need to find another model that was trained on that specific imagery. And the last one here is a Vertex AI multimodal embedded model. That one is provided by Google. Again, I've never used that one. I read a lot about it. If you are a Google engineer, you work a lot with the AI technologies from Google, I do recommend check it out. They have extensive documentation how you can actually create those embeddings from images and text using Vertex AI. And we have one more slide before we actually go and see the code and how it all works. I know I provided a lot of information. Maybe some of it makes sense, some of it is more complex. So hopefully when we move to the demo, it's gonna be more clear, and I will provide step-by-step instructions what you can do with those embedded models, specifically CLIP, and I will talk about vision language models and also provide an example of how you can use one of those models. So before we see the code, I do want to talk about a database, a vector database that you can use. One of open source options that you can use for those embeddings or vector storage is LensDB. It supports multimodal options. It is, again, open source. Then what you can do using LensDB and, for example, OpenAI Clip model, you can actually provide image inputs, you can provide text inputs. You actually don't need to match those two inputs together. So maybe you have 100 images, and also you have 100, or actually it doesn't even have to match. Maybe you have 50 text inputs and you have 100 images, and then you are creating text embeddings and image embeddings, and then actually the model itself, the clip model, will provide similarity scores. So for an image, which label from those text inputs will be data match? And then you can return the top 5 matches. Same thing goes other way. For that text or this label, what images you can return, and with the similarity score. So you can return just the first image, which is an image with higher probability, or you can return top 5 and then maybe have a human look through the results and top 5 images and then pick the best one. So it's up to you what to do with the result, but that's how it works behind the scene. And once you create those embeddings, you can create just image embeddings, you can create image and text embeddings, and then you can store maybe you have one table with just image embeddings, one table with text embeddings, and then you can search by image to get the text or label for that image. And then at the same time, you can search a different table using text and then get an image to match the text. So once you create embeddings, you just upload the embeddings to something like LensDB, and then LensDB actually can perform that search for you. So search is included there. There are lots of proprietary tools that you can use. I know that Microsoft is having that search, the cognitive search that they have. They have different vector storages. I know now SQL is supporting vectors. I'm not sure if it's fully released, but I know that it is in conversations. So they announced it. By they, I mean Microsoft, but if they released it or not, I can't tell you. But do check the options. I am gonna show you examples with LensDB and OpenAI clip models, but obviously you can use other models to create your embeddings, other storages. I honestly recommend to try different tools and see what is working better for your specific scenario. And I know I mentioned it a couple of times before, but that's how it works. There is no one perfect recipe for everything. So I am offering you a couple of options that you can use, but do go and research on your own, try different things, try with smaller data sets, try running Python notebooks, for example, Jupyter notebooks, and figure it out for yourself. And now I am gonna show you the code. And before that, I actually promised you to show an image that I generated with DALL-E 3. And it is related to two things that I really like, the cats and aerial fitness or circus. So it's a cat practicing aerial fitness routine. You're welcome. So here is the code that I want to show you. There will be two parts of this demo. One will be targeting clip models, vector search, LensDB vector database, all that exciting stuff. And then the second part will be targeting vision language models, and specifically vision language models provided by Azure OpenAI. So let's see what we have here. Today's demo is gonna be in Python. I do get a lot of questions. What language people want to use? Do they need to use Python all the time for machine learning? If they're C# developers, they're using .NET on a daily basis. Do they have to completely switch their environment and move to Python? Simple answer is no. There are lots of tools that you can use with C#. You don't have to use Python for everything. But for data science heavy tasks, it's preferred to use Python just because there are so much more libraries available in Python, so many opportunities, so many tools. They are all targeting Python because all the data scientists there are using Python. But if you don't want to do it, if you are not comfortable, if you don't want to switch your environment back and forth, there are lots of tools available for C# developers, .NET developers, TypeScript, JavaScript developers. So although today I'm showing demo in Python, there are opportunities to do something similar in other languages, or maybe use APIs and then connect them to your Python application or your TypeScript application. So let's jump into the code and see how it works. So here we have Jupyter Notebook. Doesn't have to be in the notebook. I think it's just easier to see all the code step by step using the notebook. Obviously, if you're writing your application, you need to move away the code from the notebook where you were just playing with it, training maybe your model, maybe figuring it out how it works, to actual code and to actual application. First of all, we're gonna install the datasets, transformers, Torch, and LensDB datasets. That is just for the purposes of this demo. It is datasets library with different data sets from Hugging Face, so that way we don't have to invent our own data sets. It's perfect for demo purposes, for playing with different models, but if you build your own application, you have your own data set. So we do that. It's really long. It is done. Didn't take too much time, and now we are loading one of the datasets, and that's the name of the dataset from the dataset library. Let me do that first, and I'll show you what's inside the dataset. You can see that it ran really quickly, and the output we see here is with features and a number of rows. So there are 10,000 rows in this data set, and the features are image, find label, and course label. So what that means, let me show you. Here you can see me going to the Hugging Face portal. Actually, if you are really interested in machine learning, artificial intelligence, you want to play with different models, there are different portals that you can use. I know that Microsoft actually released a really cool portal with the models that are supported on Azure, where you have Playground, you can try those models. So that's an option. Hugging Face is the place for data scientists. If you are experimenting with models, if you want to try something new, all the models they are going to Hugging Face most of the time. So lots of data sets, lots of models, whether those are vision language models, multimodal models, just large language models, small language models, they are all here inside that Hugging Face portal. There are also some portals specifically for data sets, for another types of data science experimentations, something like Kaggle. They also now have learning modules. So there are lots of different portals. I would recommend to check them out. I think they all have different models, different training, testing data sets that you can play with. So overall, there are lots of opportunities to try models, to try different data sets, to play with them, experiment with them, and then pick the best option for your application. Okay, going back to what we see here, that's the actual data set. We see that the first column has an image. It's pretty small. I talked about limitations of clip models related to size. Those images are way too small, so you can use larger images. And I personally worked with larger images, but with small images like that, it's gonna be just faster. They're gonna take less space, so when we are actually uploading them to the database or performing a search, it's just gonna be faster. So that is a perfect data set for experimenting and trying how clip model is working. And then the second column here is a label for that image. And then we have more detailed course label for the same image. So it depends what you're trying to get out of the data set, how you're trying to use the clip model. For my demo, I am gonna target find label and images. And let's go back to the code and see how it works. So we're back to the code, and you can see here that we need to install Pillow to work with images. And then we are pulling the first image from our image data. And image data came from the data set. So here, that's the image in PL format. And then find label is number 49, course label number 10. We're gonna set find label here. Those are all the find labels between 0 and 99. Those are shorter labels that we saw in the data set. And here we are pulling the names, so actual text for those numbers. And you can see there are all kinds of labels starting from apple, aquarium, fish, baby, and then finishing with woman, worm, wolf. And now we can generate sentences. So we are basically adding a label, going through each label and adding them to those sentences. And that way we are creating clip specific labels. They don't have to be in that way. So that it's not a requirement to say this is an image for and then add a label. Next time when you are working with your own data set and you want to label your own images, you don't have to say this is an image for. It is just an example. You sometimes you need to play and see what works better. Sometimes you want to label your images, sometimes you don't want to label your images. In this situation, I actually don't want to overcomplicate it. And here we are going to create embeddings just for labels, and then we'll search those labels. So we'll provide an image, and then we'll perform the vector search and return a label that matches that specific image. But there are so many different options how you can use clip models, vector databases, vector searches, and overall, you don't have to generate sentence in that way. You can just keep the labels, or you can just say this is and then a label. You need to play and figure it out for your own case. But for now, I'm just gonna run that. You can see those are the same labels, just in that this is an image for and label format. And next one, we are just gonna initialize the model, the processor here. Run that. That's the model that we are using. It's OpenAI Clip model, and that specific version. So that one is targeting larger images. That's why you can use larger images. But for this demo, again, I'm using smaller images from that data set. And here you can actually check your device. So if you have CUDA, if you have GPU, you can use that, or you can use CPU. I'm just going to use CPU today. I'm on my PC, so it's just easier to use a CPU here instead of setting up GPU. But GPU is usually much faster, so if you have access to it, I do recommend to do that. And next we'll be creating label tokens. So we are passing those clip labels that we created earlier. So all those labels here, and then we are using the device, that CPU device, and the processor from the model. And here is just the output, so we see those labels with the text. And here are the tensors with the text that we passed to it. We see that that's what the processor returned for us. Now we're going to create embeddings for our vector database so we can store those embeddings in the database. So let me just print it for now. So those are the tensors that were created by the processor. And now we're gonna use the model to actually create the embeddings. And we created, there are 100 embeddings because there were 100 labels, and that is the dimension. So let's do that just to see the minimum and maximum for those embeddings. That is not a requirement, just for the demo purposes. And then here we'll have to normalize the embeddings. That is not really critical for something small like short sentences, maybe one word labels. But if you are working with maybe longer text or you are working with images, normalization is pretty important here. So we do that. And now we're gonna pull just random image from that data set. That's the image. It's like a little cute dog. And now we actually need to feed that image to the model in order to get image embedded. So here we're gonna prep that image using processor. That's the output here. And now that's the tensor for that specific image. And that is the size of the tensor. Now we are gonna actually pass the tensor to the model. That might take a little bit. The size is one image, and that's the size of the embedding. And now here we are creating LensDB. So we just importing LensDB. And we are going through embeddings for each label. And we are saving label name and embedding to a new table called my table inside that LensDB instance. So we are creating the LensDB instance, creating a table called my table, and then uploading that data that is containing label name and embedding. And then we are preparing to query that table right away. So we are using that image embedding. So you probably remember that cute dog that we randomly pulled from the data set, and we created embedding for that image. So we're just kind of pre-processing it here, and then we are doing table search using that query embedding. And we are returning top 10 results, and we're going to print them. So let's run it. You see that it is most likely a wolf, and that is the vector for that label, and then that's the distance. The closer the distance, the more the probability is that this label relates to that specific image. So it can be a wolf, it can be a keyboard, it can be a pine tree, a maple tree, and you see that it's kind of making less and less sense. I think even the keyboard doesn't make sense. So by trying vector search, by trying different images, you see if you want to return just your top result or you want to return maybe top 3 results. Again, it depends on what kind of data you process and what kind of information you want to get. So that's it for this demo. Before I actually wrap it up and move to the second demo, I do want to show you what I got in the LensDB. We won't be able to specifically see the data because it's in a weird format, but we see that a LensDB folder created. So that's the LensDB database. And here's my table and the data. So there is actually something there. If you have an IDE or you have your maybe database shell that can process LensDB and connect to LensDB and see it maybe as a table, then you can open that file. But if not, then we know what it has. It has 2 columns, label name, and then embedding for that specific label. That's that for this specific demo. Now let's move to another example. Here I would like to show you one of the vision language models that I mentioned in my theoretical part of this talk. It is GPT-4o, so it is a multimodal model. In this case, it will cover image processing and text processing. So it works with visual information and with text. Let's see how it works. So here we just installing some libraries. Again, it is just a Jupyter notebook for the purposes of this demo. It is a good way to play with different libraries to see how the models work. Maybe you are grabbing those models for the first time, but once you pick the right model and the right approach, you can obviously move away from Jupyter notebooks and into actual application. So we installed all of that, and then now we are setting up our environment, so importing some libraries, and let's do that first here. And then next we are just pulling some information from that environment file, and there I have OpenAI API key and OpenAI API base. I actually created a resource on Azure, and then I opened that resource in the Azure AI Foundry, and there I created specifically GPT-4o model, and I grabbed the key and the URL, the base URL from Azure AI Foundry portal for that specific model. At the same time, I grabbed the API version and the model name from there as well. I am not going to show you my keys and the base URL. So let me run this one here. It ran, it didn't actually do much. I just set up the key and the base. And then here's the main function. Here I have the system prompt. You can update it as you want. You can also pass it as a variable. I am just hard coding it here. And then I'm using that base URL here and the model name, API version, and the key when I am initializing that initial Azure OpenAI client here. And then I'm using that client to create completions. For completions, I'm using system prompt from here. I'm using the prompt that I'm going to pass as a parameter, and I am going to use an image URL here. There are a couple of options. You can use image URL if you have that image posted somewhere online, or you can actually post an image, use that PIL format, use base64 format. There are a couple of approaches. So in this case, I'm just using URL, but you don't have to have that image online. You can have it saved maybe where your project is. Maybe you are saving it on your hard drive. Maybe you pull in actually base64 representation from your database. There are lots of options. Right here, it's just gonna be a URL. I'm setting up temperature really low because I want it to be more accurate and precise and not making up stuff. Max tokens, again, up to you. I just put 512 here, and then the frequency penalty so it doesn't repeat a lot of information. And that's the function. So let me run it. It doesn't do much yet, but here's the image URL. Let me show you the image first. So that's the image that I pulled online. That is from the Olympics that happened this year. So you can see. And then I'm going back here. I just want GPT-4o model to analyze this image, so I'm passing the text. It's going to be here as a prompt, and then the image URL from here. And then I am returning the final results here and just printing them out. So let's run that really quick. It might take a little bit. And here's the result. Let me open it in text editor so it is easier to see. Oh yeah, that is a read-only file. Then we'll do it this way. The image shows the Arc de Triomphe, in Paris, illuminated at night with projections related to the 2024 Summer Olympics. The projections include hashtag Paris 2024 at the top, indicating support for Paris as a candidate city for hosting the 2024 Olympic Games. The sides of the arc display colorful graphics and text that read Paris along with candidate city Olympic Games 2024. Additionally, there are symbols of the Olympic rings reinforcing Paris' bid to host this major international sporting event. The scene is set against the dark sky, highlighting the vibrant lights and colors projected into this iconic moment. So, really nice description. I actually really like it. It is accurate. It is written nicely. You can definitely play with system prompt. I just kept it really basic. So you can tweak the prompt, the system prompt, you can tweak the user prompt to get better results. If you want something different, you can also return the result in JSON format. So if you collecting the result and then processing it further down the line, that might be a good option here as well. So that's that for the vision language model demo with GPT-4o model. And let me switch back to the slides. That's it. That's everything that I wanted to cover today in this talk. And here I just want to remind you about Festive Tech Calendar. Please go check their website. The organizers, the speakers, they're doing an amazing job. There are so many great videos, great blog posts, great content all around. So I do recommend to check other content that is available, and I know that there's something new every day.
Thank you so much for joining me today. I hope you learned a couple of things about the power of multimodal models, and you can go ahead and start playing with them, whether you're working with vision language models or you're trying speech and text models or other modalities. It is always fun to play with something new, to implement new technology, to try different models with different applications. Again, if you have any questions, don't hesitate to reach out to me either through Twitter or X or LinkedIn. I am always happy to help you and to answer your questions. And again, I would like to thank the organizers of Festive Tech Calendar. Every day throughout the month of December, there is new content being posted, so I do recommend to actually go and check the content that was posted before this talk and also after this talk. I know there are lots of blog posts and conversations and amazing videos. So I'm wishing you happy holidays, and I hope to see you next year. Thank you.